Hello, this is Mr. Best. Welcome to Chapter 7, Proof in Quadrilaterals. This is the closure, questions 147 to 156. Question 147. Julius set his hinge mirror so that its angle was 72 degrees, and the core region was isosceles, as shown at the right. How many sides did his resulting polygon have? Show your work. So to be able to figure out how many sides, remember a full rotation would be 360 degrees. So if that angle is 72 degrees, then if you take that and divide by 72 degrees, that will give you 5, which means there's 5 sides because there will be 5 angles of 72 degrees, and those triangles are isosceles as it said, so there'll be a total of 5 sides when your angle that is formed with the hinge mirror is 72 degrees. What is another name for this polygon? Well, if it has 5 sides, then this would be a regular polygon. Question 148. Kelly started the proof below to show that line segment TC is congruent to line segment TM, and AT, line segment, bisects angle CTM. Then line segment CA is congruent to line segment MA. Copy and complete the proof. So part of it's already filled in, as you can see, and we just got to go through and fill in the rest of the parts. So the first thing that is stated is what's given to us. So I'm going to mark this also on the figure that TC is congruent to TM, and if angle or line AT bisects angle CTM, which is this angle right here, if it bisects it, then it's going to cut that angle into 2 equal parts, which in turn will mean that these 2 angles are congruent. But you can see the second one here says definition of bisect. So if it bisects it, then we want to say that angle, let's go CTA, is congruent to angle MTA. And we know that because of the definition of a bisect. Yes, that's part of your what's given, but it still is the definition of a bisect as to why those 2 angles are congruent. Next part, line segment AT is congruent to line segment AT, and we know that because of the reflexive property. Alright, and then number 4, they're both blank. But where do you go from here? Well, you have a side, an angle, and a side. So we can now say that the 2 triangles are congruent. So triangle CAT is congruent to triangle MAT. Alright, and we know that because of the side, angle, side congruency. And then the last thing, remember what we were trying to prove is that these 2 side lengths CA is congruent to MA. But we only know that once we prove that the triangles are congruent. So now we know that CA, line segment CA, is congruent to line segment MA. And we know that because congruent triangles give you congruent parts. And so once again, you do have a 2-column proof, but more of a kind of fill in as you go along here. Question 149. Examine the spinner at the right. Part A. Find the expected value of the spinner if x equals 4. So if x is equal to 4, we can break this up into different parts. So we can see that that's a right angle, so that's 1/4 of what the spinner is. Now 135 degrees. How do we figure out how much of the circle that is? Well, remember, it's 135 out of 360. And when you reduce that, or divide and then change it back to a fraction, you get 3/8. So this would be 3/8 of the circle. And then it appears that those are the same, just to make sure. The whole thing should add up to 1. So if we do 3/8 and 3/8, that's 6/8 plus 1/4, which is 2/8. So that does add up there, so that's good. So find the expected value if the spinner is 4. Well, we have 16 times 3/8 plus, if it's 4, it'd be times 3/8 plus negative 12 times 1/4. So 16 times 3/8 would be 6. 4 times 3/8 would be 3/2, or 1.5. And then negative 12 times 1/4 would be minus 3. So if we add that up, that's going to be 7.5 minus 3, which would be, where am I at? Yeah, 7.5 minus 3. And so that would be 4.5. So the expected value when x is equal to 4 is 4.5. Part B, now we want to change the x value here to a negative 8. Now let's see what happens. So changing it quite a bit in terms of the difference would be an 12 values there. Let's see what happens. So the 16 still stays times 3/8, but now it's going to be minus 8 times 3/8, and then the minus 12 times 1/4 still stays the same. So we're only changing the x value. So 16 times 3/8, once again, is 6. 8 times 3/8 would be 3, so that's minus 3. And then 12 times 1/4 is 3. So 6 minus 3 is 0. When your expected value is 0, that means it's a fair spinner. So you expect to be ahead as much as you are behind on that one. It just, over time, you ideally are going to break even. On C, it says find x so that the expected value of the spinner is 6. So now we want to set it up. We want to say, okay, well, we know we're going to have 16 times 3/8. That can't change. We know we're going to have the minus 12 times 1/4. But then what does x have to be? So we're just going to say plus x, but we know it's times 3/8, and we want the expected value to be 6. So we're going to set it equal to 6, and then we'll just solve. So this will be 6 minus 3, and then this will just be plus 3/8 x is equal to 6. So 6 minus 3 is 3. So 3 plus 3/8 x is equal to 6. Subtract the 3. And we're just solving a linear equation. Multiply by 8, divide by 3, and x is equal to 8. So if the expected value is going to be, if we want it to be 6, then we need the x value to equal 8. Question 150. ABCD is a parallelogram. At A is 3, negative 4. So we're just going to plot these points. 3, negative 4. So here's A. B is at 6, 2. C is at 4, 6. And then, where are the possible locations for D? Draw and graph and justify your answer. So if this is a parallelogram, and we're connecting here, we have this one and then this one. And since it's a parallelogram, we know that we don't have it drawn in yet, but this side over here would have to be parallel to wherever this other side is going to be. And then this one would be parallel across. So if we can find the slope for AB, which we can just do a slope triangle, we're going to go up 4, 5, 6 over 3. Then the same thing should happen on the other one, is that the slope should be up 6 over 3, which is 2. And so you can kind of work backwards. If I go, that would be a slope of 2, 2, 2. And so it's going to be somewhere along that line. And then we also want the slope for BC to be the same as AD. And so that slope is you're going up 4 over 2, so that would be 2. But it is in the negative direction. So think about this point. If I go up 2 over 1, that creates that same slope of negative 2. And so point D would fall at the value 1, 0. Problem 151. Each problem below gives the endpoints of a segment. Find the coordinates of the midpoint of that segment. Once again, lots of different ways we can look at this. The way the book kind of approaches it is to think, okay, I'm going from negative 3 to 5. And so just to kind of give you a visual if you're struggling a little bit, negative 3 to 5. What's that total distance? Well, that total distance is 8. And you can find the total distance by taking the larger number minus the smaller. And so that's 8. And then we want to cut it in half. So we want the midpoint, which is that half that distance. So we want to go 4. So then we can just go 4 units from negative 3. So negative 3 plus 4 would put me at 1. Or you can do 5, because you can go the other direction, 2, 5 minus 4, which will still put you at 1. So the x-coordinate is 1, comma. And then you can do the same thing with the y-coordinates. It goes from 6 to 11. Oops. So that difference, 11 minus 6 is 5. Half of that is 2.5. So you could add 2.5 onto 6, and that would give you 8.5, or subtract 2.5 from 11. So 1, comma, 8.5 would be the midpoint. I'm going to go ahead and show you a second way that some of you might be using. And the second way is just to kind of find the average of your x's. That will find the midpoint of those. So for example, you take your x-coordinates and divide by 2, and then you take your y-coordinates and divide by 2. So this would be negative 4 plus 8 divided by 2, and then y would be negative 1 plus 9 divided by 2. So that'd be 4 divided by 2 is 2, and 8 divided by 2 is 4. So, part A is a little bit more visual, getting you to kind of think through the process. B is more kind of, an algorithm, just plugging in and figuring out what that midpoint is. But either one is fine. Question 152. For each diagram below, solve for the variable. So the first one, we're looking at a right triangle. We have the hypotenuse and the adjacent leg that we're trying to find. So since we are dealing with the right triangle, we can use our trig ratios. And which one uses adjacent and hypotenuse? That would be cosine. So cosine of 42 degrees is equal to the adjacent over the hypotenuse. And then we can multiply both sides by 10. 10 times cosine of 42 degrees is equal to x. And then you can plug that into your calculator to get an approximate value of 7.43 units. And remember to make sure your calculator is in degrees. On part B, we have an isosceles triangle. So these two side lengths are both x, which means we also know that the two opposite angles are the same, which means they're 25 degrees. And then all three angles have to add up to 180. So 180 minus 25 minus 25, or 180 minus 50, would be 130 degrees. And so we are not dealing with the right triangle on this one, which means we can use maybe law of sines or law of cosines. And because we have enough of the angle measures, we can use law of sines. So we can go with sine of 130 degrees over 15 is equal to sine of 25 degrees over x. And then we can multiply, you can cross multiply or multiply both sides by 15x. That would be x times sine of 130 degrees is equal to 15 times sine of 25 degrees. And then to get x by itself, we can divide by sine of 130 degrees. Plug that in your calculator, and we'll get x as approximately 8.28 units. Part C. This one we're looking for an angle measure. It is a right angle, or a right triangle I should say, so we can use our trig ratios. And this one is opposite and hypotenuse, so therefore remember opposite side is across from the angle. So we can use sine, so we'll write this as sine of theta is equal to the ratio of 10 over 18. And then to plug this in your calculator though, because we're looking for the angle, we have to use the inverse of sine. So we're looking for the inverse of sine of 10/18, and that will give us the angle of theta. So theta is approximately 33.7 degrees. And once again, make sure you are pressing inverse of sine to get that angle measure. Question 153. On graph paper, draw quadrilateral MNPQ given the four coordinates. So you can see I went ahead and plotted the points and drew the parallel or the quadrilateral. Part A wants us to find the slopes of line segment MN and line segment NP, and what can we conclude about angle MNP after doing that. So line segment MN is going to have a slope of, I'm just going to do slope triangle. So we're going to go up 1, 2, 3, 4, 5 and over 3. So therefore my slope is 5/3. And then I'm going to do the same thing with NP. So I'm looking for line segment NP and the slope of that line. And so for NP, if I go from N to P, I'm going to go down 3 and to the right 5. So my slope would be -3/5. And since you can see the slopes are opposite reciprocal, then we know line segment MN is perpendicular to line segment NP. Which then it says, make a conclusion about angle. Well, that means that angle MNP is a right angle. Because if it's perpendicular, then it forms a right angle. All right, part B. What is the best name for the quadrilateral MNPQ? And justify your reason. So right now we know that NM and NP are perpendicular. What about the side lengths? Well, if all the side lengths, because you're going to do your Pythagorean theorem, so like for example, if I do PQ and I draw in that slope triangle, that's going to be 3 and 5. And then the same thing here, I have 3 and 5. So all 4 side lengths, when you go to do Pythagorean theorem, you're going to get 3 squared plus 5 squared is equal to c squared. And so we can figure out what this is, but we know they're all going to be the same. And so we get 34 equals c squared, so therefore the length of all 4 sides are going to be the square root of 34. So we know all the sides are the same, which is part of what a square is, but we also have to decide, is it a square or a rhombus? Well, are all of these angles right angles? And you can see in terms of the slope, we already did MN and MP. If you do PQ, you can see that the slope is up 5 over 3, so that means it's perpendicular to this one. And then this one over here is up 3 to the left 5, so it's negative 3/5, once again making this a right angle as well. So it does appear, based on what we just talked about, that the best name for this figure would be a square because all 4 sides are congruent and it creates 4 right angles. Alright, so I wrote some additional things there kind of down about a square. That's important. Now part C. Which diagonal is longer? Explain how you know your answer is correct. Because it's a square, the diagonals should have equal length. And just to, once again, we can verify that. You have this diagonal, and you can create, once again, a right triangle from that. So it looks like we're going to have 2, and then that goes up 1, 2, 3, 4, 5, 6, 7, 8. So 2 and 8, so that'd be 2 squared plus 8 squared is equal to, it's called y squared. That's 4 plus 64, and so that's going to be 68. So y is going to equal the square root of 68. Is that same thing going to happen on the other diagonal? If it's a square, it should. So this distance right here, once again, I kind of got a lot going on with all the Pythagorean theorem stuff, but you can once again create a right angle going this way. So you can see that's 2, and once again, it'll be 8 across. So the diagonals will be the same length. So they are equal. And we know that because, once again, because it's a square, and also because we actually calculated the distance to be the square root of 68. And last one on to D. D is find the midpoint of MN. So if we go back up here just to make sure, M is 1, 7. N is negative 2, 2. So to find the midpoint, a couple different ways you can do this. You can find the distance between 1 and negative 2 on your x coordinates. So that would be a distance of 3, and then half of that is 1.5. So your midpoint then, if you go 1.5 in between, would be negative 0.5. And then the 7 and the 2, that would be a difference of 5, and so you would add 2.5. So it looks like you get negative 0.5 and 4.5. The other way that you can do that, remember, is to add up your x's and divide by 2, kind of just like finding the average here. Add up your y's and divide by 2, and you can see that's going to be negative 1 over 2 and then 9 over 2, which is the same thing as what we did there. So either one of those is fine. Question 154. Examine the geometric relationships in each of the diagrams below. For each one, write and solve an equation to find the value of the variable. Name any geometric property or conjecture that you used. So on part A, you might notice that this line segment splits the 2 sides into congruent parts. So those 2 sides are congruent, and then these 2 sides are congruent, and that's the triangle mid-segment theorem. So we know that this triangle, is similar to the overall bigger triangle by twice the size, because you have, this length is half of the full length. So we get rid of some of that stuff, which means that this side, 3m plus 5, has to be half of 5m plus 11, because the triangles are similar, so they have the same ratio. So we could do one of 2 things. We could take 2 times the smaller length and set that equal to the larger length, or we could take half of the larger length and equal to the smaller length. Either one is fine. Let's go ahead and do the first one. This would be 6m plus 10 is equal to 5m plus 11. So if I subtract 5m, I get m. If I subtract 10, I get 1. So m is equal to 1. Alright, I added the triangle mid-segment theorem because it does say name any property or conjecture that you used. Let's go to B. B, PQRS is a rhombus with a perimeter of 28 units. PR is equal to 8 units. Find B, or QT. So remember, a rhombus, by definition, has all of the sides equal to each other. So if we know that the perimeter is 28, if we divide that by 4, then each of these sides would represent 7 units. It also says that PR, this entire distance, is 8 units. We also know with a rhombus the diagonals bisect each other, so if that's 8, then each of these individual side lengths are 4. And then also one of the things about the diagonals is they are perpendicular bisectors. So not only do they bisect, but they're also perpendicular, which means they form a right angle. So all of those triangles in there are right angles, and it has a length of 4. You're missing the leg, and then you have the hypotenuse is 7. So we can use Pythagorean theorem to say 4 squared plus b squared should be equal to 7 squared. So 16 plus b squared is equal to 49. Subtract 16 from 49, and you get 33. And then take the square root, and b is equal to the square root of 33. And so b will be approximately 5.74 units. And so on that one, we used a couple things. We used the diagonals of the rhombus are not just perpendicular, but they're also bisectors, and we also used Pythagorean theorem. All right, and then once again, I added that to why we knew what we knew. Part C, we have two parallel lines cut by a transversal. So we know vertical angles are equal to each other. We also know corresponding angles, so this would be corresponding, are equal to each other. And then we have straight angles, we know add up to 180 degrees. So we can say 3x plus 17 plus x minus 5 is equal to 180 degrees. So combine your like terms, 4x plus 12 is equal to 180 degrees. Subtract the 12 from 180, and that would be 168 degrees, and then divide by 4, and that will get you 42 degrees. So x is equal to 42 degrees. Once again, I didn't really need, I guess, the vertical, so I didn't use that one. I used more of the corresponding, and then also used straight angles. All right, part D, we have a kite. You have your consecutive sides congruent here and here, and then it also gives you those angles. So with a kite, your opposite angles, one pair of opposite angles, these right here in terms of where your sides are congruent to each other. So 2x minus 5 is equal to x plus 13. And we can solve by subtracting x, adding 5, and x is equal to 18 degrees. Question 155. Given the information in the diagram below, prove that triangle WXY, which would be this one, is congruent to YZW, which is this one. So you're trying to prove that they are congruent. And I went ahead and put the answer on here as a flow chart, but this is the part that's given to you. You know that WZ and XY are parallel to each other, and since you know they're parallel, when you cut by this transversal WY, then that means your alternate interior angles are congruent, so that would be those two, and that angle would be labeled ZWY, and then the other one would be labeled XYZ. So that's where that part comes from right here. and we know that because if lines are parallel, then alternate interior angles are congruent. We also know that angle Z and angle X are congruent because they're given to you, so you can already see they're already marked, so that's why that's given. And then WY and YW are congruent to each other by the reflexive property. And so now that means we have angle, angle, side, and that's enough to prove congruency. So therefore we know that triangle XYW, and make sure you get it in the correct order. And when I say the correct order here, X has to match up with angle Z. So this X has to be congruent with angle Z, which you can see is true. This Y has to be congruent with W. So when you say X, Y, W, that's this one. And then Z, W, Y would be this one. So that matches up. And then the W and the Y have to match up as well. So just make sure that you are matching them up correctly. And we finally know that by angle, angle, side congruency. And so this one was done as a flow chart. You could have done it as a two-column proof also. And lastly, question 156, must be, could be. Here are some more challenges from Mr. Quincy. For each description of the quadrilateral below, say what special type of quadrilateral must be or what special type of quadrilateral could be. Remember, some descriptions may have no must be statements, and some descriptions may have many could be statements. So the first one is the diagonals of a quadrilateral are equal. So the diagonals of a quadrilateral are equal. So is there anything it must be? So the first thing you might think about is a rectangle. Must it be a rectangle, though? What else are the diagonals equal? Well, a square. So you can't say it must be a rectangle if it could also be a square. Anything else where the diagonals would be equal? The other possibility would be a trapezoid, but it's a very specific type of trapezoid, and it'd have to be an isosceles trapezoid. So it appears on A, there is no must be's, there's none. And then on the could be's, we have three. We have it could be a rectangle, could be a square, or it could be an isosceles trapezoid. So no must be's on that one, only could be's. B, the quadrilateral or my quadrilateral has one right angle. One right angle. So think about that. Once again, you might go to a rectangle first, but then it could also be a square. Could also be a trapezoid if it's a right trapezoid. But then the other problem we did the other day, or in class, if you remember, we had a right angle, one right angle, and it wasn't any special triangle, or any special quadrilateral, sorry. So can you have one right angle and then just have any random shape there? And the answer to that is yes. So just because you have one right angle doesn't mean you have any special type of quadrilateral. So on this one, we actually have, once again, no must-be's. So there's none. And then the could-be's, yeah, it could be a rectangle, could be a square, or no, it can be a rectangle square, sorry, those have more than one right angle, so this one's saying specifically just one right angle. So if it's just one right angle, then it could be, any quadrilateral. So you could have lateral. So you could have any quadrilateral as long as it has one right angle, but it doesn't have to be, once again, it's not going to be one of your specific ones. Sorry about that if that was a little confusing there. C, we have my quadrilateral has one pair of equal adjacent sides. So read that again. My quadrilateral has one pair of equal adjacent sides. So think about, once again, adjacent sides are sides that are right next to each other. Okay, so those are adjacent sides. So what things have equal adjacent sides? Well, you got your square and your rhombus, because all four of those sides are the same. So square and rhombus. So maybe it must be a rhombus, could be a square. But the other one you might be forgetting is the kite, because remember the kite, you have two sets of pairs actually that are equal adjacent sides. So once again, it appears on this one because that kite throws off the must be. There is no must be. There's none. And then there's three options in terms of what it could be. So it could be a kite, could be a rhombus, or it could be a square. And so that is it for the closure questions. Once again, on the must be and the could be, just think of all the different properties and what you're looking for, and just make sure you have them all kind of labeled out as to what you're looking at. And then, is there any of them that must be true? And then after that, what are the could be's?